We're going to look at problem solving by integration. So occasionally we can actually be given a rate of change of a variable, and it's, in practical sense, it's explained that sometimes it's easier to measure the rate of change than to measure the actual quantity. So we can get the rate of change of the variable, and then if we use integration, we can actually find an original function. So the example we've got here is the marginal cost of producing X earns a week is given by this function. Now, marginal cost, which I didn't actually know what it meant before doing this question, is it's the cost of producing an extra unit after you've already made a unit. So let me just read out the definition. The cost added by producing one additional unit of a product or service. So the idea is that we're making earns, and every time we make one after it, it's given by this rate. So we've got this function here, dollars per earn produced over an interval. So it looks like we can make 0 to 120 earns. The initial cost before production starts $185, and find the total cost of producing 100 earns per day. So the first thing we've got to do is, and this is the big hint here, is earns a week. We're given, when we're given a rate like that, we're looking at, well, X is going to be the amount of earns in this, the earns that we can make. So, well, this is the earns made in a week, and then we're looking at dollars per earn. So let's just do the integral here. So X is earns, and obviously our function is going to be our dollars, the cost in dollars. So I'm going to use C here because the question actually gave us this integral here. So I'm thinking C has an input value of X. So we've got this cost function of X, and it should equal the integral of 2.15 minus 0.02 X plus 0.0036 X squared. All right, and we do the integral of this, so it's with respect to X, dx. Now, you can actually, this is up to you, and I'm leaving it as a preference, but I would consider, and I prefer writing things in fractions as opposed to decimals. I think decimals leave you in a space that you can make a mistake. So 2.15 minus 2 over 0 tenths hundredths, so over 100 X, and then tenths, hundredths, thousandths, tens of thousands. So we're going to look 10,000, 10,000, 100,000. So now I probably wouldn't go to this level when this decimal here is so full on, but just because you've got tens, thousands, tens, hundreds, thousands, 10,000s, 100,000. So just, it's up to you there. I just personally find this makes it a little bit easier. Okay, so let's do the integral of this. We get 2.15x for the first term. This next one's going to be minus 2 over 100 x squared over 2. So we're going to have that 2 and that 2 are going to cancel there. And then plus 36 over 100,000. And then you've got here x cubed over 3. So 36 divided by 3 is 12. So we can go change that to a 12 up there and cancel those out. All right, you can do it in the calculator. You can do it yourself. I just prefer this. This is really easy to follow, and easy to follow if there's an issue in there. Now we've got plus C, where C is a real number. Cool. So the next bit we're specified. So we can clean this up if we want, but let's just leave it for the. No, we'll do it here. 2.15x minus x squared on 100, and then plus x cubed sorry, 12x cubed on 100,000. All right, the next thing we've got, so we've done the integral here, so sweet, we've done our first bit. Our interval here, we haven't started graphing yet, we've still got to figure out what C is. The initial costs before production starts are $185, so that means here C0 is going to equal $185. So we've found, this is our cost function here. Okay, so plus C. So therefore C of 0 equals 185. Therefore C equals 185. So we've got that purely based on 0 will cancel that, 0 will cancel that, 0 will cancel that. We'll be just left with C. Okay, the next bit there is we've got the final bit of this problem. So we've finally got our function here. Now, I typed this derivative function in my calculator in y1. If I now put this function in y2 and then dy dx in, so if I put this function here in y1, I put this function here, now I know it, c of x equals 2.15 x minus x squared over 100 plus 12x cubed over 100,000 plus 185. So if I type that in my calculator, which I'm going to quickly do now, and I suggest you do the same, 2.15 minus 2.15x minus x squared over 100 plus 12x cubed over 100, 3,000. That's got to be careful there, 185. Now, the reason I've done that is I've put this here in y2, and then my y3 equals d dx y2 x equals x. Now this will check my function for me. So when I draw these, I should get, now my view window is not set up right, so I need to change my view window to match. So my view window x min equals 0, x max equals 120. So I'm doing that to sort of sort out this. Now my y min and max, I'm looking at this here and I'm looking at the total cost. So I've got 185 is my initial cost. It's obviously going to cost more than that. So let's just go 0. We know we're in the hundreds. Let's just go 500 for our max. Okay, so now I can draw this graph. Okay. Now, it's really hard to see because I'm actually seeing that these two are so small in scale. So I'm going to get rid of that and I'm just going to draw. This might seem a little bit crazy, so I'm just going to quickly change that to 1, exit, draw. Do I get a function here? No, it's bigger than, I need to, so I'm just pressing max here. I just want to figure out what the max of this function here is because it's a parabola. So we should have a max value, and I did not get one up there. So draw. Okay, I'm chewing up time now. Let's just finish this question and I will come back to this. Oh. Okay. So I would do this as a check. Most of the time you wouldn't end up, this function here, it's because you've got this giant thing here that's just wrecking our, let's just go 10 maybe. I'm just trying one more time. Okay, I've got the function. So with a view window, playing around a little bit, I've got to y min equals 0, y max equals 10. And I can see this is a parabola, and I can find the minimum here. And the minimum for both functions here is 1.87. It's at 27.5. So they both match, and I see they're the same function. So that's good. Now I just put my values in. So now we've got to calculate 100 earns equals 2.15 100 minus 100 squared over 100 plus 12 100 cubed over 100,000 plus 185. So this becomes 215 minus 100 times 100 over 100. So I can cancel out 100 and 100 plus 12 times 100 times 100 times 100 over 100,000. So just if we were doing this algebraically, cross off a 0 there, 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 and now we're over 1. So this now becomes simpler to do, equals 215 minus 100 plus 185. Okay, plus 12 times 10 is 120, plus 185. Okay, should equal 220 plus 80 is 300. This should be $420 there, 420. Now, if I have my graph set up right, so I change my view window back to a y max of 500. If I draw this, and this is where it's up to you if you do this or not. I'm just trying to give you extra tools here. Gsolve 100, and I get, I'm on the wrong function. 100 is 420, perfect. All right, I'm just going to stop there. I'm going to do this as two videos.